Well, hello, fans of biblical genetics. This is Dr. Rob. I'm coming to you once again from CMI Studio. I'm here because I just finished recording a four-part podcast series with the Patterns of Evidence people. If you know Tim Mahoney, my dear friend, and his movie series on Egypt and the timing of the Israelites coming out of Egypt and the route of the Exodus. Patterns of Evidence, patternsofevidence.com. This was for Patterns Plus, which is a subscription service. Go to patternsofevidence.com/patterns-plus. You can find it if you like. But the besides the Pattern Plus video series, the audio is available for free on the Patterns of Evidence podcast, which you can pretty much find anywhere. But we are very busy here at Biblical Genetics. I just got back from a tour of northern Indiana. I landed in South Bend Airport, and I was going to go to a town in southern Michigan, just 2 hours away from where I was, a town that is named after the biblical name for the underworld. But there was a giant snowstorm when I landed. In fact, that town, it was a cold day there. One might even say it was frozen over. Now, why would I skirt around breaking the third commandment here on biblical genetics? It's because something incredible has happened, something unexpected, something non probable. And that is that Erica Gutzik Gibbon has admitted to massive mistakes on video. Yes, she has. In fact, I'm going to go through several of them just for the sake of completion. I do not wish to belabor this point any further, but just so everyone understands what's going on. There has been a large series of videos uh, put out by multiple people on the work of Dr. Jeffrey Tomkins, my friend, my colleague at the Creation Research Society. He works at um, Institute for Creation Research. I work at Creation Ministries International, two very different organizations. He and I disagree on a few things, but not on everything. And he has gone on record multiple times looking at the similarity between humans and chimpanzees or genetic differences, and he come out with some very low numbers, which I don't necessarily agree with. I'm not saying he's wrong. I'm just saying that I have a very different approach, and my numbers are higher, and I'm working down to see how far I can go, but I'm not quite there yet. But now, not taking this sitting down, a whole bunch of antagonists have published videos. This is Gutzik Gibbon, Ruhif, and Creation Myths, and a couple of the people. But on the protagonist side, Standing for Truth, Apologetics 101, and me here on Biblical Genetics, we've all published videos trying to say that the situation is not nearly as bad as some people think. But there is this question, not of the accuracy of the original reports, but the accuracy of the current analyses. I don't trust the people doing the critical analysis. And now I have evidence why. I'm going to point out several glaring problems, but not to gloat, not at all. This is an exercise in science. It's an exercise in how do we know, how do we follow evidence, what do we do when we make a mistake. And I want to compliment Erica right off the bat here because she admitted right in public, out loud, on camera, and put it out for all of her people to see that she made some tremendous mistakes. And so, just to explain what happened, I'm going to go through a little more details, and hopefully, we get to put this aside because I got other things I want to do. In fact, I had moved on from this entirely until I realized what happened. And this actually in December, I realized what happened. I did some analyses. Sure enough, I figured out what she had done. And then last week here, now we're in January, she came out with her My Culpa video and explained the problem. And yeah, I was correct about her being incorrect. That kind of makes sense, though I have made my own mistakes in this series also. But I pointed out in my last video on this subject that we should be applying James chapter 3, verses 1 and 2. Not many of you should presume to be teachers, my brothers, and I said, and sisters, for you know that we who will teach will be judged with greater strictness, for we all stumble in many ways. Yeah, it is difficult to be a scientist. It is difficult to be a person in public being a scientist. It's difficult to say something and later on realize that you're wrong, or even worse, have someone else point out that you are wrong. That's a very hard thing. But also, teachers are judged doubly, just like pastors should be judged doubly. People who are out in public saying things are true or things are not true, they should be held to a double standard. Politicians also. They really, I mean, people who are saying this is the way things are, if it ain't so, that person should have some sort of a social penalty applied to them. I don't know what to say. We're not going to pillory people anymore, but we should at least call them to the carpet when a mistake has been made. All right. I also warned Erica in my last video that eating crow was hard enough, but eating crow, when it's covered in a heaping helping of snark, makes it extremely bitter. And yet, in her video, when she's acknowledging these things, she very calmly and very actually pleasantly, politely went through the things and admitted to the mistakes. And I just wanted to make sure that everyone knows what they were. Again, not the gloat, but just so that we can um, understand better this whole human chimpanzee similarity issue. Um, you see, it's okay to contradict somebody. It's okay to think someone is like the world's worst scientist. It's okay to think someone's just a train wreck of an analytical disaster and everything they do is just wrong. Fine, you could think that. But if you're making similar mistakes along the path of you're trying to contradict somebody, that's not good. And so here's the first one. The first big mistake that was made was a failure to understand the basic features of this computer program that was being used to assess human chimpanzee similarity. It's a program called BLAST. What BLAST does, it starts off by taking a genome and breaking it up into 11-letter words by default, and it makes a dictionary of those. And then when you take another genome, you try to find that sequence in the first genome. You take 11 letters and you find it. Ah, there it is. And you try to extend in that second genome, the target genome. You try to extend the match. And the misunderstanding was that if you had like 1,000 letters and you had 1,000 letters that you're querying on your 1,000-letter target, what if there's a gap in the middle? Well, the first 500 would line up beautifully and the second 500 would line up terribly. So the assumption was that the report would come back with a terrible match, but that's not true. As I pointed out in my video, the program is looking for local areas of best alignment. So it'll find the 500 first letters fit beautifully and the second half don't. It's not going to report like a 50% alignment or 60% alignment. It's going to report 100% alignment, but only on the first 500 letters. And it'll skip over the second 500 because that's garbage alignment, and it would know it. And this was just not understood. And yet, massive numbers of calculations are being run. All these analyses are coming in, data is being analyzed, and yet she did not even understand what she was trying to see, what she was looking at. And granted, anyone who's new to a field can make newbie errors. I understand that. And I've made plenty myself. And every time I get into a field, I'm like, I don't know what I'm doing. But I don't typically talk in public when I don't know what I'm doing as I'm savaging someone else's reputation. That's a very awkward place to be. So one mistake was made. The second mistake, to explain this, I want to use the subject of data analysis as a topic. Let's imagine that we're on a data analysis highway and we're trying to get to the end where we can write our final report. All right, so going down this highway, there are exits. And at every exit, there's a test. And if you fail the test, you must get off the highway. Okay, so that's our analogy. Data analysis highway, tests, and forced exits if you ever fail a test. Now, you might be able to get back up on the highway again right away. You might have to adjust your data. You might have to do another test. You might have to get on a different highway, or you might have to just pack up and go home. If the data fail, you can't continue. And yet, the data did fail because she didn't run a test, and she didn't know it, and she kept going. Now, this is something I noticed. I found a massive problem in the data. And Jeff didn't notice this. He didn't expect it. Most people wouldn't actually. But when I graphed his percent identity values of these sequences from the chimpanzee that I was using to compare to humans, I noticed that a lot of them were very low percent identity. And a lot of them were very high percent identity. and there's almost nothing in between. And he took the average of all that and got about 85%. Ooh, but you can't do that. You can't take the average of, what was it, 69% to 98% and get in the middle. That's not, you can't do that. There's nothing there. There was nothing in the 85% range, and yet that is the average of these two mountain peaks. But you must get off the highway at this point, and you must stop and think, what am I looking at? Why are there all these sequences that match very poorly to the chimpanzee genome? Well, a lot of those are highly repetitive sequences. That's the most dissimilar types of sequence between human and chimpanzee, is all the repetitive stuff, the so-called junk DNA, if you would. But we don't know if the laboratory that collected all these sequences, because there's a lot of them that are very repetitive. About half of the sequences were in the low percent identity category, and half of them are in a high percent identity category. Do we know that that's an accurate reflection of the chimpanzee genome? There's a lot of repetitive DNA in this data set. Is there that much repetitive DNA in the chimpanzee genome? If it's wrong, if there's too much repetitive DNA in that sample or too little, you don't have a good reflection of the chimpanzee genome, so you can't keep going down the highway. The data are not going to tell you human versus chimpanzee similarity. They can't do it if you don't have a good sampling, a fair sampling, I called it, of the chimpanzee genome. And no one ran the test. So sorry, stop right there. You're done. Anything you say after this is invalid because you don't actually know if it's true or not. And yet she kept on going down the highway like I've done before. A lot of other people do this as scientists, is a common mistake in science. And yet it was definitely made, and we saw it happen. Ruhif did notice something, though, and this is troubling. He noticed, and he put it in his video, that when he took a chimpanzee sequence and compared it to the human, he knows, like, let's just, for example, you had a 1,000-piece DNA segment, and you put it on human, and 900 letters lined up, but the first 100 letters didn't line up. And he said, okay, what is that 100-letter sequence? And that's a cool question. I wish I had thought of that, but I didn't think about that. But what is that 100-letter sequence? So he took that and he compared it to all the genomes that have ever been sequenced online using BLAST. And it turned out that it flagged a lot of viral and bacterial sequences, not chimpanzee and not human. Where does that come from? Well, in genetics, we use bacterial enzymes, we use bacterial linker sequences, viral promoters, we use antibiotic resistance genes from bacteria. We use a lot of viral and bacterial sequences to do all the things that we have to do in genetics, to copy DNA, to clone DNA. Very often in the genome sequencing projects, the human chromosomes are made into what are called bacterial artificial chromosomes. And we let the bacteria, as they grow, they make copies of the human genome, the chromosomes. Then you can kill the bacteria and pull the chromosomes out. Now you have lots of copies of your chromosome. You let the bacteria do the work. But in order to do that, you need pieces of the bacterial genome in there. And apparently, this initial data set was contaminated with bacterial and viral DNA. Ouch. Now, I didn't notice that. Jeff didn't notice that. Erica didn't notice that. If Ruhif is correct, see, I say if because he only did a small sample. He didn't do all the thousands upon thousands, but he did find some, and wow, that's casting shade on the Eichler lab that produced these data. Because what these things are, they're called contigs, or contiguous DNA elements. They're not sequencing results. It's not what comes out of the machine. They've actually been lined up and linked together into groups of things that line up very easily. And they have all these pieces of DNA lined up. They read the average out of that, and that is a contig that should have been cleaned up. Now, Tomkins did trim the ends off of his contigs on purpose because he knew that there's tend to be error prone at the ends. No, I didn't do that, but Tomkins did do that. Okay, but none of us thought to look for contamination of that, but Ruhif did. And so here's an antagonist attacking Tomkins, and he finds something that, whoa, what? The Eichler lab left viral DNA fragments in their chimpanzee data. That's not good. But okay, so anyway, the data analysis highway. At that point, you can't continue. You can't use these data to assess human chimpanzee similarity. So we know that, well, we don't know that they're evenly balanced. We don't know that these contigs are a good sampling of the chimpanzee genome. So even if even if there weren't any of the other problems, just the question of is it a fair sampling means you can't continue. You can't adjust the scores based on length, or called weighting, W-E-I-G-H-T. Weighting is irrelevant if you don't have a fair sampling. I'm going to plant my flag on that because that is the truth. I don't think anyone should have continued down the road, but people have. But the third and most important mistake that Gutzek Gibbon made was completely bungling the analysis, and in a way that I never would have thought of at first. In fact, I'm going through my video.
But Erica, your computer program is not producing results that match reality. I showed you theoretically why that's not true, experimentally why that's not true. You should not be getting, using any setting of blast, an 85% similarity when you're blasting something against itself. There's no parameter setting that will do that. So I'm wondering if you yourself found a result that was too good to be true and then ran with it. I'm asking you honestly. And now I'm asking if that's true, if on the record you'll go back and say, okay, I was wrong. Because you keep on saying that Tomkins needs to say he's wrong, he's wrong, he's wrong, he's wrong, he's not admitting it. Well, are you going to admit it if you're wrong? Compare your computer program, ask your husband about it, have him look at my computer program, look at them. Let's see who's doing what's wrong here. Because I'm getting the results I expect, and you're not getting the results I'm expecting, and I cannot figure out what's wrong.
Now, a couple of weeks later, I did figure it out. Wait a minute, this is what happened. I realized that when you turn off a feature in BLAST, it will give you a bunch of garbage results. Usually, we're looking for the best match. So very often we'll set a match is called a sequence pair. So we'll set the computer program to say, just give me one high scoring sequence pair, the highest scoring sequence pair. Don't give me anything else. But if you turn that off, you can set it to 10 or 20 or 50. But if you turn it off, you get all the matches. And remember, BLAST starts off with 11 letters. So it'll take your query sequence, it'll break it into 11 letter sequences and try to find those pieces in the other genome. And then if you find it, it'll start extending and it'll give you all these matches back, theoretically, possibly. And if you averaged all the garbage, what would you get? Well, to get at that, I took 1,000 base pair random sequence from each of the human chromosomes in the telomere to telomere genome. And I blasted against itself. Now, you should get 100% match. But when you turn off high scoring sequence pairs and let it report everything, you get a lot more than that. In fact, I got 36.6 million matches from 25 sequences that are only 1,000 letters long. And the results were really stunning. First of all, so I'm just picking random pieces, right? I got one, my thing from chromosome 4 had like almost 7 million matches, but chromosome 5, 6, and 7 had hardly any. Chromosome 9 had a couple of million, 13, 19, 22. Just because I picked a random place that just happened to have a lot of other places in the genome with pieces that also aligned. Okay, so this is not good. But then I graphed them. I graphed just the first 100 hits from each of my 25 sequences. And the first one was always at 100% identity. And after that, it trailed off. And if I take the average of that, the average is very interesting. In fact, if you take the average of all of these, all my millions of hits, you get a percent identity of 86.6%. So I knew a month ago that that's what Erica had done. And I was wondering, should I publish this first, or should I wait till her response video to see how she responds? And then holidays happened, and I waited, and sure enough, she came out and she admitted to doing exactly that. Um, this is not good. So I knew that when you take a sequence and blast it against itself, you will get a result back with 100% identity, always. An E value or expect value of 0, because you never expect to find this by chance. The number of identical letters will equal the number you search for, in this case 1,000. The length of the match will be 1,000. There'll be 0 mismatches. There'll be 0 gaps. The bit score is just a calculation. In this case, is 1829 is a score, because it's like, X number of points for a match. And it turns out to be 1829. Okay, fine. But the chromosome that comes back is always the same in the query and the target. So 100% identity, no gaps, no mismatches, the same exact length, the same exact chromosome. In other words, BLAST is finding the exact correct match. Take a random piece out of any chromosome and throw it the same chromosome, and you'll get the same exact match, which is why Jeff in his paper said he got 100% identity when he did self versus self. So why is Gutsa Gibbon getting 86% identity? It's because she's looking at all the garbage also. 86.6%, that's the average that I got for these 25 things. It's very similar to what she did. And sure enough, she published her program on GitHub. So I went to the GitHub and I found the program. There's a bunch of files in there. I figured out which one it was, and I'm scanning through this, and I'm looking at it, and it's right there. The program will take the blast results file, it'll open it up, and it will go for every row in the file. Each row is a hit for every single row. I'm looking at it, and it says p-ident sum plus equals parse float of p-ident. In other words, add up all the percent identity values, make a sum of everything in this potentially very long list, and then later on, unweighted equals the percent identity sum divided by the total length. She just averaged potentially millions of nonsense spurious results. That is not what Tomkins did. It's clear from his papers that is not what he did. And yet, because she didn't understand the program, she went and claimed that that she reproduced Tomkins' method when she did not. See, there's a fourth failing here. It's called confirmation bias. This is a very tricky thing, and all humans are subject to this. And clearly, this is true here also. She got a result that she expected, and because of that, she thought she had reproduced the methods, and she had not at all, not even close, had reproduced the methods. So confirmation bias is a bugbear in science. It is a very difficult thing to deal with, and we just saw a classic example of it right here. Now, with all these problems that have now been aired out, and we know this is happening, I can't trust anything coming out of her or a group of people associated with her. Not at all. Everything must be carefully checked. Every statement must be analyzed. Nothing can be taken at face value. That's why in my last episode, I said basically I don't trust what's coming out from the other side. Well, we have a demonstrable bias. We have a demonstrable misunderstanding of things. A very lightweight understanding of the techniques and the techniques used, and yet they're going to jump in and just start, in the mosh pit of ideas. I'm right, and you're all stupid, and yet you don't know what you're talking about. Doesn't mean she's wrong, but I mean so far she hasn't been right for any of the right reasons. um, Look, I'm just gonna leave it at that. I respect Erica in a lot of ways, and even creation myths and even Ruhif in some ways. They're not wrong about everything, but they are showing an extreme level of bias in a lot of ways, and it's clear from the stuff that they're producing. So really, I know that they might watch us and get mad at this point, but this is for my supporters and for the Christian base out there. We know that the enemy, as the Bible calls it, is difficult and dangerous. We know that we shouldn't expect to be treated fairly, but it doesn't give us a martyr complex that should make us be very circumspect about ourselves. We need to be careful about the way we present ourselves in public, and we need to be very careful about the analyses we do and the conclusions we draw, because we are as subject to these sorts of mistakes as anybody else. But it, all right, to be admit, it does bring me quite a bit of pleasure to know that Erica has made these mistakes. I'll just say it that way. But I'm not gloating. Again, I'm actually humbled because I know that I've made the same mistakes in my career. Hopefully, not often in public, but I know it's definitely possible. And I'm going to leave you with Philippians chapter 2, verses 3, and I'll see how far I read because this is a very interesting passage. This is Paul exhorting the church in Philippi. Do nothing from selfish ambition or conceit, but in humility count others more significant than yourselves. Let each of you look not only to his own interests, but also to the interests of others. Have this mind among yourselves, which is yours in Christ Jesus. So that's the basic Christian approach. And I know it's extremely hard to meet that standard. Extremely hard. But we're told to behave like that. And we need to. Whether or not the other side does or not doesn't matter. We need to. And we can encourage the other side to behave similarly. We'll see what happens. But the reason that we approach life that way is because of the next part. Jesus Christ, who, though he was in the form of God, did not count equality with God a thing to be grasped, but emptied himself. That's the famous kenosis word. He emptied himself by taking the form of a servant, being born in the likeness of men, and being found in human form, he humbled himself by becoming obedient to the point of death, even to death on a cross. My Christian friends, we are called to emulate that. That's why we treat everyone with humility. That's why we try to treat people with respect. Because we, as incredible sinful beings, with all the failures of any other human being, all the lust, all the anger, all the greed, all the sloth, I mean, we are, all the classic sins fall on our heads also. But Jesus didn't fall into any of them. But he became in the likeness of a human being. Are you kidding me? Why would he do that? And he humbled himself to the point where he allowed his body to be put to death on a Roman cross. That's the context in which we're supposed to interact with other people. And yet, uh, the great victory happens in Christ. Therefore, Paul continues, God has highly exalted him, that is Jesus, and bestowed on him the name that is above every name, so that the name of Jesus every knee should bow, in heaven and on earth and under the earth, and every tongue confess that Jesus is Lord, to the glory of God the Father. All right, my friends at Biblical Genetics, do I hate my opponents? The answer is absolutely not. In fact, it would bring me no end of joy to spend eternity praising Jesus with Gutzon Gibbon, or creation myths, or Ruhif, or any number of other antagonists out there. Some of them are going to come to our side. Some of them, not going to be many, not according to history anyway, unless there's some great revival happening in the halls of science, which I very much doubt. But some of them are going to come to our side. And we need to hold out the hand of welcome. And we need to hold out a humble hand also, because we're no better than them. In fact, in some ways, I'm worse. I know my sinfulness, only this much. But God knows it fully. I don't want to know it fully, but I know it a little bit, and I know how bad I am. And yet here I am in public, trying to defend Scripture, trying to defend scriptural science, trying to address errors other people are making. Oh, that's scary. That's really scary. And yet, God is true and God is good, and God is with his children, and I am one of his children. Now, if you are not a believer, that is, you don't believe in the claims of Jesus and basic Christianity, we can have a conversation if you like. Anyone out there listening, if you've made it this far, we can have a conversation. I would encourage you to go to creation.com and look, and at least get your scientific questions answered about the Bible, but there are some theological things there also. And maybe you just need to plug yourself into a good church or find a good teacher, a good pastor, and just start listening. It's not something that usually happens instantaneously, though it has happened most people take a good long while thinking and pondering before they come into Christianity. It's not too late for you either. Well, thank you for listening. Now, no, I'm not a televangelist, and I'm not asking for money, but I do have a cadre of people who are supporting me on Patreon.com and on BuyMeACoffee.com. No, it's not real coffee. That's just $3 tips, and I really appreciate all those people. I would not be able to do this without them. Specifically, the camera I'm using. This is new. These earphones I borrowed from a friend here at work so I could film my last thing. I just kept them on so that I could record this real quick. God bless you all. Thank you so much for helping. Thank you so much for your support. And thank you for sharing my videos with other people, talking about them with other people, and just clicking the like button. Thank you so much for listening on podcast. I really appreciate it. My podcast audience is little smaller than my video audience, but it is growing. And I really love it when I hear someone say, "Hey, Carter, I listen to your podcast all the time." That just brings a joy to my heart. And I hope I've encouraged some of you some way and maybe challenged a few others. Goodbye.